So in this particular episode, what we will be discussing about is regression analysis. Okay, so that's our topic. Our correlation is already done. If you have not seen that video, please do go and see that, and then you'll have a better concept to study this regression. Okay, so what is regression? So we know that there will be a correlation between two variables, right? Whether it could be dependent, independent, or it could be between multiples as well. It does not really matter. It could be one constant, one independent, one dependent affecting on others, or combined effect of independent on a single variable. Okay, so how do we use that to predict some data? Okay, so that is basically what the regression analysis will give us. It will give us the equation which will provide us the slope or the area in the slope, and that will help us to predict it. Okay, so what is regression analysis? Regression analysis is a statistical technique of studying the functional relationship between dependent variable and a group of independent variables to predict the average value of dependent variable in terms of known values of independent variable. So this is used to predict. Okay, so you could even use this thing to predict a rough estimate of what your future values or what the dependent values might be due to a twist in independent variable. Okay, so it will basically provide us that thing. Okay, so when was it first used by? It was used by Sir Francis Galton at 1877. So nearly 10, 25, 20, nearly 145 years ago, nearly 143, 142 years ago. Okay, so by Sir Francis Galton, first used term. Okay, so what is its use? Its use is to estimate average relationship between dependent and independent variable. Okay, and then to measure the effect of each independent variable. So you could twist that particular variable, right? So you could basically say that, like, suppose if we're looking at weight and height and weight, so you could twist the height or you could twist the weight. So how will that impact on the dependent variable, which is the weight, right? So that is used to explain the variation. Okay, so and then to predict the dependent variable for a given values of independent variable, so you could use that for that as well. So by twisting the a's, right? So you could increase the a's, decrease the a's, height, decrease, increase. How will that impact our weight on the other side, right? And what are its types? It's simple regression and multiple regression. So what is simple regression? When there are only one dependent and one independent variable, that is simple regression. And then after that, multiple regression is more than two variables. Okay, so the combined effect of two on one. Okay, or you could say like there could be same as that, like height, weight, height, age, and then weight, right? So three variables. So we will look at the simple regression, whether it is y on x or x on y. Let's look at that. That will give us a bit of clarity. So we will first of all compute the correlation, and then how much will that. So we will compute an equation, and then we will put a values in the independent variable, and then see how much independent variable we'll try to predict. Okay, so you can't really say like you can actually predict the exact values, but somewhat close to the direction should be pretty much same. Okay, so let's look at simple regression first of all. So in case of simple regression, so it is, how do we find the line of a regression equation, right? So in case of simple regression, it is a relationship between two variables. Okay, so it's a regression analysis between two variables, both dependent and independent. Okay, so one is dependent on the other, So if x and y are two variables, and if y is a function of x, then y is dependent on x, right? So any change in x will change y. So if it is x on y, then x is a dependent variable on y, right? So x is a function of y, right? So there will be one single dependent variable, one independent variable, whereas in case of multiple regression, there will be between two variables. It is between dependent and independent, but there will be more than one independent variables. There will be multiple, okay? That's the basic difference. So for example, you could say like this is, so suppose if the x and y is weight, and the other thing is, suppose this is x and then this y is height, right? So these are two variables, right? In this case, so this is a dependent variable, this is the independent variable, right? As you can see, height, if it increases or decreases, the weight will differ, right? So it's a x is a function of y, okay? So you could change it, it's interchangeable, okay? So you could write this as y and then this as x, and then we use this function, okay? So you can twist it anyways you want to. So in case of multiple regression, what happens is that you will have one dependent variable and then more than one or two or three independent variables, okay? So in this case, the regression analysis is the study or the relationship between, we are trying to find out the line of linear equation between multiple independent variables, okay? So example could be weight. So weight might depend on height, age, diet, well-being, right? So there are four different independent variables which might affect weight, okay? So that equation will be a bit different from the simple regression and a bit longer as well, okay? So how do we obtain the methods of, uh, how do you obtain the line of regression equation? So you could obtain it by methods of taking deviation from respective mean. How much does it deviate from the actual mean, right? And then the other method is method of least square. So first of all, what we will do is that we will discuss how much will it differ from, or we take the deviation from respective means. We will use this method. So I find it easy just to use this A method as well. You could definitely explain B as well. So, but when we are solving the problems later on, we will be using number A, okay? So I find that pretty easy and then just easier to do, you know? So yeah, let's look at this particular method. How do we compute it using this particular method, okay? So the first method that we were talking about is deviation from the mean, right? So how do we calculate using that? So what we do is that regression equation of y on x. So I'm not doing x on y, but y on x. That means y is your dependent variable, x is your independent variable, right? So the first equation that we write is that we know we have done this particular problem very much. So y is equals to a plus byx plus x, okay? It's not plus. It's x only. Okay, so what is that? So basically, you are basically trying to find out what is the slope, okay? So what is your intercept? Where will it intercept between the two lines, okay? And then after that, if it is over here, and then we multiply it by the slope, how much up or down we must go, right? So that's what this basically equation tells us, okay? So where your y is your a is your y-intercept, and then your byx is a slope of y on x. Okay. So what we do first of all is that we multiply it by summation. Okay. So when we multiply it, the only thing that we need to look at is summation y is equals to n times a, because anything that you're multiplying it with, if you do n, so n is an imaginary number, right? So that's why we are using n, okay? So basically n times a will be how much is the number by n, that will increase the intercept. Okay, so byx is your slope of y on x, and then this is your summation x. Okay, so next what we'll do is that we will divide this equation by n. So when you divide it by n, summation y by n is equals to na upon n, where n and n will be cut, and then plus byx dot or multiplied by summation x divided by n, right? So do you see this particular thing? Don't you think this is what we already know? Yep, it is the mean. Okay, so we can replace that value, right, by mean. So when you're computing any means, what we normally do is that use this formula, summation y by n or summation x by n, right? So we are replacing that particular values. Okay, so now our equation will be, so which will be our second equation, which will be y dash is equals to a plus byx x dash. Okay, so next what we'll do is that we will subtract equation 2 from equation 1. Okay, from this we will subtract this. So it will be y minus yx is equals to a minus a plus byx x minus you could say slope of y on x times x bar. Okay, so what will happen? A and a will be cancelled out, and then you will have byx and then slope, you could say slope into your x bar, right? So what we will do is that we will take the slope common, and then x minus x bar. Okay, so this will be our formula for calculating regression, for calculating the values, okay, of the dependent variable. So the other formula that we can use is that for calculating the byx. So how will you get byx? Is that you could basically multiply the correlation by the standard deviation of y upon standard deviation of x. You could use this first formula, or what you could do is that, because that is the deviation from how much has it deviated from y, and then how much has it deviated from x. So and then the correlation that will give us the angle, right, or the point. So byx is like if you're using assume mean method. Okay, so in this actual mean method, I mean, so if you're using that, what we normally do is that we normally multiply x minus x bar and then y minus y bar. Okay, that's a summation as well, and then the next thing we divide it by x minus x bar whole square. Okay, so if you're writing it in short form, you could say x is x minus x bar, y is y minus y bar. So if you're writing it in simple terms, you could just write it in this much thing. Okay, so the next is using direct method. You could find the slope of y on x using direct method as well. What we normally do is that n times summation x times y minus summation x dot or multiplied by summation y upon your n times x square or summation x square minus summation x whole square. Okay, so this will be a direct method. So in case of byx, just the same thing. All you're doing is replacing that x by dx dy, and then the same thing in the formula as well. Pretty same formula, just the denotation is different, and what they mean is also different. So in this case, dx is x minus a. So it's x minus the assumed mean or your whatever mean that you're assuming. Okay, and in case of dy, it is same thing. So in the second column as well, you will imagine something is a mean, and then after that you will deduct y minus that value. Okay, so that will be a bit clear. You know this concept already from your bachelor's or wherever you've studied. So I will do some examples, and then that will give us a bit of clarity more. So in this 5 number, so it's about byx. So this is step deviation method. As we know, in step deviation method, everything is same. All we are changing from assumed mean method is that just it will be a dash dash dash, and then you will multiply it by k times h dash. Okay, that's what we will basically do. We will multiply by the common factor. So where d dash x is, or dx dash is x minus a upon h. So where a is your assuming and h is your common factor. Okay, so it's like 10 to 20, your common factor is 10. So 5 to 10, your common factor is 5. So we will do that for same x for the first variable as well, and then for the second variable as well. Okay, so that's how we basically compute the standard deviations. So this is for just a normal equation. So if there is only two variables, dependent, independent, and then if there are dependent variable and multiple dependent variables, then we will need to use different method. We will talk about that as well. So this is our first method. So next what I'll do is that, so basically x on y or y on x, it's interchangeable, right? So if we are using, if you are doing x on y, then we just replace the values. Okay, so x, it will be x is equals to a plus byx y. So that will be our first equation. So it will just be interchangeable, pretty much same, but just the values will be a bit different. That's pretty much it. Otherwise, everything is same. So if you're thinking like, if your question gives you like, okay, let's say if the question is like this, in this format, okay. So if it gives your height at the beginning and then your weight is down below, okay. So you could say height 1, 2, 3, 3, 2, 1, right? So if this is thing, so what you normally do is that you normally tend to write height as x because it's at the top, and then weight will be your y, right? Or you could write like, yeah, you could do that. And then when you're making your columns, what you could do is that you could consider weight as your y and then height as your x. Okay, so you can change it. It doesn't really matter. So basically, if you remember x on y, then you can use x on y only. Or if you're remembering y on x, you could use y on x. I mean x on y only. So it just depends on your, which you find easier or whatever your, it's just same thing. Okay, so you can just interchange the variables and then use this particular equations. Okay, so let's look at the next method of calculating the line of equation. Okay, in the first method, as we've discussed, right, x on y on x, right? So we will look at x on y as well. So in this, what we will do is that, the basic example, right? Basic, I mean, the equation a plus byx or xy dot y, right? So this will be your first equation where your a dash, okay, this will be a dash. In the other one, it will be a only because it is a x-intercept, okay? And then bxy is a slope of x on y, okay? Not y on x on y. And then you will multiply it with the summation sign, and then you will basically get this equation divided by n. You will get this equation, because since this is summation x by n is mean, and then we can write it as x bar, right? So that's why we will get this second equation, and then what we will do is that subtract second from first, okay? So if you are subtracting it, it will be x minus x bar is equals to a dash minus a dash, and then bx, or slope of x on y times y minus slope of x on y times y dash. Taking bxy common, you will get this particular equation, right? So after that, what will happen is that after that, you could use like basically after subtracting it, you will basically get this particular values. You will get the slope and then the intercept, and based on that, what you will do is that you will compute the other dependent variables, or dependent variables estimated value. Okay, that's what we will basically be doing. So a can be computed as summation x minus slope of y on x, and then summation y upon n. Okay, so this can be written as x bar minus slope y on x times y bar, right? So other formulas that you can use to calculate bxy or slope is that all these formulas which we have already discussed earlier as well. So everything is same basically. All the formulas are same. You could use actual mean method, direct method, assume mean method, step deviation method, whichever method you prefer. It will be easier. Okay, so if you are using step deviation method, as you know the drill already, that we don't have to compute large number of data, right? So we don't have to do squares and stuff like that. So it will make it pretty easier. Okay, so that's pretty much it. So next one we will look at regression of multiple or multiple regression equation. Okay, so in this second method, so what we will do is that we will use the least square for obtaining our regression equation. Okay, so how is this, what is this basically, you could ask that question. So it is basically a mathematical device for obtaining equation of a curve which best fits the set of observations. Okay, for any set of observations which best fits it. Okay, so it is basically you're finding out the same thing, just the equation, and then just a different method only. Okay, so that we use to predict the values. Okay, so how will we, it is based on the assumption that the sum of the square of difference between estimated values square and then the actual the values observed or values of observation is least. That's what it is based upon. Its assumption is that. Okay, this is very important thing. So as I told, we will be using very less of this method, but we will be using the other method because I prefer that. And if you want me to do this method as well, I'll do it. Doesn't really matter. So basically, what is the assumption that is based on is that sum of square between estimated values and actual observation or actual observed value of observation is least. That's its assumption. Okay. So how is it done? How is it computed? So if it is a regression equation of y on x, then what we will do is that you know the normal equation, right? Which is basically y is equals to a plus bx, right? That's our normal equation. So where b is your slope, right? It's like by on x kind of thing, right? So b is your slope, a is your intercept, right? So what we will do is that in case of normal equation, what we used to do is that we used to multiply it by the summation, right? So if you multiply it by summation, you will get this equation where you will be, all you need to remember is that summation y is equals to n times a, because whatever you're multiplying it with, suppose we are assuming that the number is something else. Okay, so we are multiplying it by n times a. Okay, so in case of b, in case of the third equation, what it will be is that we will multiply it by x. Okay, so what we will get after that is that summation x multiplied by y is equals to a summation x, and then we will get x square as well, b times, b is a constant, and then b times summation x square. Okay, so where a and b is your constant, does not really change. You could change these values over here, it will be changed. So equation of best fit will be then, what you can do is that you can replace this by, or what you could do is that y is your expected value, and then a is your expected value, and then b is your expected or estimated value, and then you multiply it by x. Okay, so this will be your best fit equation. Okay, so this will be your last values after you compute it from here. Then you will get this particular values where you will basically estimate the values of a and b, and then after that what we will do is that what is this independent variable, if the question has given it, we will multiply that by the slope, and then we will get our y values. Okay, so if it is Same thing again, x on y, then only the thing changes. So x will be a function of y, right? So we know the normal equation, x is equals to a dash plus b dash y, and then normal equation multiply by summation, and then again multiply by y, and then where your a dash and b dash is your constant, and then equation which best fits is basically x hat is equals to a dash hat plus b dash hat times y, where a is your intercept, b is your slope, right? So this is basically how we use this second method of least square for obtaining regression equation. The main observation being that the square of the difference between estimated value and actual observation or actual observed value of observation is least. Okay, so we assume that it is minimum. Okay, or least, Okay, so what we will do next is that we will look at few problems, or not few problems, but we will look at multiple regression analysis, and then we will move on to problems after that. Okay, so let's look at multiple um, regression. Until now, we were just talking about multiple regression analysis, right? So I mean, simple regression analysis. So what is that? So we were only looking at only one dependent variable and one independent variable, right? So how would the change on y on x or b on x, how will that basically affect the how will the independent variable affect the dependent variable, right? That's what we are looking at. So in case of multiple regression analysis, what we will do is that we will look at the effect of combined effect of two or more independent variable on the dependent variable. Okay, so as you can see, so simple regression analysis was the linear relationship between dependent and one independent variable, only one. Okay, so it is a logical extension of simple regression analysis. So it's a build up on that, right? So in this case, more than one independent variable is used. Okay. So what is the objective? You might ask as well. So why are we trying to compute multiple regression using two or more independent variables? Is that because see, like weight, height, age, right? So weight is not only affected by height, right, or age only. So it might be affected by a combination of these two independent variables, right? That's why we require multiple regression analysis, or we need to find out the multiple regression equation. Okay, so we will be finding out that. Okay, that is the main thing. That's why we need to use multiple regression analysis. What is the objective? So it is to derive an equation which provides estimate of the dependent variable from the known values of two or more independent variable. Okay, so it provides us the estimate of dependent variable from the known values of two or more independent variable. Okay, so this is basically obtained from least square method. Least square method. So basically what we do is we create equation, and then after that we subtract 4 and 5 or 3 or 5 from there. Okay, so we subtract between the equations, and then we find out b1, and then after that we find out b2, and then we solve it. Okay, so this objective is obtained using least square method, right? We have already done that method as well, but this one is a bit slightly different. So we will look at that as well. That will give us a bit of clarity. So to measure the coefficients of multiple determination or proportion of variation in independent variable is explained by independent variable, right? So this is basically computed because whatever determination you actually get. So first of all, what you do is you compute the equation. After that, you will get your coefficients. So what we will do is that we will square that coefficients, and then that will give us the variance. Okay, so it will help us explain how much the change within that particular thing is. So suppose I give you an example as well. So suppose your thing is 0.8. Okay, so suppose if you square it, you will get 0.64, right? So 64% of variation is due to the independent variable. So out of the total variation in the dependent variable. Okay, that's how we know. So this objective is for that. Okay, and then to obtain the measure of error in the regression equation as a basis of for estimation of the dependent variable. So how much will that error be, and how much will that impact the dependent variable? That's what we will be looking at. So that is the third objective. Okay, so that when we do the formulas about standard error, that will make us a bit clear. But all you need to remember is that basically what we are trying to do is that how will the combined effect of independent variable affect the dependent variable, and how much will that particular independent variable explain the variations in dependent variable, and then we try to estimate the error as well, so that we have a correct dependent variable. Okay, so what we will do now is that we will look at few more of this regression. So we will look at the different methods of doing it, so that will give us a bit of clarity as well. Okay, to find out multiple regression equation, what we need to first of all determine is that which is the independent variable, which is the dependent variable. Okay, so there will be multiple of independent variable, right? So it could be 3, 4, whatever, you know. So first of all, what we will do is that, so suppose you are assuming anything to be a dependent variable. So let's suppose x1 is a dependent variable, okay, on x2 and x3. Okay, so I'll write it from this way. So suppose this is your dependent variable, these two are your independent variable, right? So what we will do is that the first equation that will be is the point where it intercepts b1 x2 plus b2 x3. Okay, so this will be your first equation. So where what is it, where x2 and x3 is your independent variable, x1 is your dependent variable, right? A is your intercept, and b1 and b2 is your slope, right? Okay, so what we will do is that we will multiply this particular equation with summation. Okay, so let's do it. When we multiply it by summation, what will happen is that, so summation of x1 is equals to n times a, because whatever you're multiplying by, you can express it as n, right? That's an imaginary number. So suppose x1 is equals to n times a plus, what we need to do is that b1 summation x2 is here, right? Plus b2 summation x3 is here, right? This is the equation number 2. Okay, so next what we will do is that we will multiply all this number by x2. Okay, so then we will get this equation, x1 dot x2 is equals to a times x2 plus b1 x2 square. Okay, x2 into x2, x square, x2 square, right? Plus b2 x2 dot x3. This will be your third equation. After this, what we will do is that we will multiply this equation again with x3. Okay, our third independent variable, or second independent variable, you can say. x1 dot x3 is equals to a times x3 plus b x2 x3, okay, b1 x2 dot x3 plus b2 x3 square, okay. So this will be our fourth equation. So after this, what we will do is that we will put the values of various numbers, okay. So suppose when you have computed the x1 or x1 dot x2, we will put in the values, then we will use the matrix system, okay, to calculate the first of all we will calculate a. First of all, we will use this, we'll calculate the coefficients, and then we will assume any x2 or x3, any independent variable, and then we will fit it in the equation, and then we will get our dependent variable x1, okay. So suppose what will happen is, after this what you will do is that you will write, you will basically make an equation after you put all these values. So what we will do is that we will write a, and whatever values is with a, we will write it down over here, and then b1 again, then b2, and then constant, which is the values before the is equals to, okay. After that, we will use the matrix system. So we will learn that in the what do you say, in the questions again, okay, when you are solving the problems. So the thing that I want to tell you right now is that, so I'll just give you a bit of example, okay. So x1 is equals to, so you might get a is the delta 1 divided by delta, right. So a, suppose you get 5 plus 0.75 x2 plus 0.9 x3. So you might get this equation after you have put in the values of a, b1 and b2, okay. So when the question has given you x2 and x3, now we fit that in this equation, and then we will get our x1, okay. So it's just the same thing. I'll teach you something else as well. So what we will do is, let's erase this as well, and let's erase this as well. So let's change our independent and dependent variable, how it will vary, okay. That's what I'm going to show you. So y on x1 and x2. So what will be the equation now? It will be y is equals to a plus b1 x1 plus b2 x2, okay. Summation of y is equals to n times a plus b1 summation x1 plus b2 summation x2, right. So this is your equation after you multiplied it with the summation, right. This is the second equation. So what will be the third equation then? It will be basically you multiply it with x1, okay. x1y is equals to x1a plus b1 x1 square plus b2 x2 dot x1, okay. That's what we will do. After that, we will multiply it with x2, right. x2 dot a plus b1 x1 only plus b2 x2 square, okay. So that will be a third equation. After that, we will again remove the values from the a, b1 as well, b2 as well, constant, keep it at the side, use the matrix method, compute a and b, and then put that values in this equation, and then after that we will basically put the values for x1 and x2, the independent variables, then we will get our y, okay. So you could do the same thing for x2 on x1 and x3. Okay, I'll give you an example as well. So x2 on x1 and x3. So x2 is equals to a plus b1 x1 plus b2 x3. That will be your first equation. Okay. So what we do next is that we multiply it with summation, right? N times a b1 x1 b2 x3, right? That will be your second equation. And then after that, what we'll do, we'll multiply it with x1. Okay. The first independent variable, x1 x2 x1a plus b1 x1 square b2 x1 dot x3. Okay, so next what we will do is that we multiply it with, okay, so it's 2 on 3, right? 2 x3a plus b1 x1 plus b2 x3 square. Okay, so normally in the third equation, the square will be in the middle. Okay, it will be in the last. Okay, so always remember that we are multiplying by the independent variable. Okay, in the order. So that's a technique of remembering. Same thing again, but what we will do now is that we will be using deviation from mean. Okay, so suppose x1 is your dependent variable. Okay, so same thing, we will use the same equation again. We won't have the a-intercept over here. Okay, we will only have the bx2 plus b2 x3. Okay, we will just have this much in our equation. So this, why am I writing small x? Because x is x minus x bar, right? So small x is x minus x bar, right? So that's your mean from x, right? So how much has it deviated? That's what we are just trying to find out in that. So next thing what we will do, same thing again, we will multiply this by summation x1 is equals to b1 summation x2 plus b2 summation x3, right? So you will have these figures in the table that you computed, and then after that what we will do is x1 dot x2 is equals to b1 x2 square. Okay, we will square it plus b2 x2 dot x3. Okay, next is x1 dot x3 is equals to b1 times x2 dot x3 plus b2 times x3 square. Okay, so this will be our equation, right? So first, second, third, fourth equation, right? So after this, we will put in the values for between in this three equations, and then we will use our matrix method, find out b1 and b2, right? And then after that, what we will do next is that the only thing difference is when we are opening. So let's suppose this x1 is equals to b1 x2 plus b2 x3, right? So what we will do is that we will basically x minus x1 is equals to b1 x2 minus x2 bar plus b2 x3 minus x3 bar. Okay, so we will only change this much at the end only. Okay, so that will be, we will just put the values in after that and we will get our answer. Okay, that's pretty same. So next thing we will look at is deviation from simple mean and then from simple correlation. Okay, how can we compute it using standard deviation? So this was one another example. So the only thing that you need to remember over here was it was same as the earlier thing, same equation 1, 2, 3, 4, and then the only change is after you have computed your b1 and b2, you will just replace, or you will just open this small x, we will make it into big X. Okay, that's what we will basically be doing. So let's move on to standard mean from simple mean and standard deviation. Okay, in this case, so we'll be using mean, standard deviation, and simple correlation as well together. Okay, so if it is x1 on x2 and x3, so our equation will be x1 is equals to a times 8a, 1 is 1.23, right? So that is the combined effect of 2 on a, right? So b12.3, right? And then after that 3 being constant, okay, x2, and then b13.2 x3, okay. So the only thing we are doing over here now is that we will need to open, this is a small x, so we will make it into bigger X, which is x minus x bar is here, how much has it deviated from the mean, right? So basically we will get our this is the you are subtracting it from the mean, right? So and then b2, same thing, you are opening x2, okay, you are opening x3 again in the second step, and in the third step, I mean in this step where b12.3 is, you know the formula already, so standard deviation, and then standard deviation of first variable divided by standard deviation of second variable. And then what we will do is that we will use the formula, this formula, and we will get our b12.3, okay. And then in this case where b3 has, how much effect will 3 has on 1 will be looked at by standard deviation of first divided by standard deviation of third, right? And then after that r13 minus r12, so 13 minus r12 times r23, okay, divided by 1 minus r23 whole square, okay. So we will put in this thing over here in case of b12.3, where we will just replace the b, so it will be x minus x bar, and then same thing down below, and then we still have this x bar, we will multiply it by that x minus x2 mean over mean, x2 minus its mean, and then same thing over here from b13.2, substituting it, and then we will just do the, we'll just multiply it with x3 minus x3 bar, okay. So this is pretty much it that we will need to use, or this formula is, or this equation we will need to use to compute it if you are only given mean, standard deviation, and simple correlation, okay. So we will look at standard error and quotients, okay. So when we are finding out the coefficients of multiple determination, what we need to be looking at is that what is the dependent variable, what is the independent variable, you know the drill already. So in this case, we are assuming that x1 is the dependent variable, x2 and x3 is the independent variable, okay. So what we will do is that, so 1 is dependent on 2 and 3, so your formula will be a times summation x1 plus b1 times summation x1 dot x3, okay, x2 I mean, plus b2, then summation x1 times x3 minus n times your x1 mean whole square, okay, see over here, divided by summation x1 square minus n times x1 square, okay. So this is only mean square, not summation of x1 square, okay. Remember that, don't be confused with the sign. And then after that you still have a square over here, so after that what will happen is when you remove this square, it will be under root, right? So this is your, that how you will compute your coefficient of multiple determination. Whereas, so sometimes as we discussed earlier, that suppose if you're if it has already been taken from the mean, right? So suppose your, if the deviation is taken from the mean, then we will use this formula, okay. So there will be no a, and then after that your r12.23 will be b1 summation x1 times x2 plus b2 summation x1 times x3 divided by summation x1 square, okay. So suppose if this would be a bit different, let's say 2.13, right? So b1 So x2 x1 plus b2 x2 x3 divided by summation x3 whole square. Just replacing the values only. Okay, that's pretty similar. Okay, in this uppercase as well, it's the same thing. All we need to be careful about is whether it has been taken from the mean or directly. Okay, we just need to figure that out, and then based on that we will calculate our coefficient. Okay, so what we will do next is that let's look at standard errors as well. So when you are computing your standard error of estimate, what formula we'll use is this formulas. Okay, so standard error of estimate, right? So based on that, so you will use a standard deviation 1.23 of, you know, the formula for standard deviation, right? So under root summation x minus x bar x hat, you can say, square under minus n minus 3. Why is it 3? Because it is a number of variable. Okay, so 3 is your number of variable. So you can compute it this way as well. You could use the other way as well, which is basically all you need to do is that under root, summation x1 squared minus a summation x1 minus b1 summation x1 dot x2, then minus b2 summation x1 dot x3 divided by n minus 3. Okay, so you could use that as well. So in case if 1 is dependent on 2 and 3, okay, suppose if 2 is dependent on 3 and 2, 2 is dependent on 1 and 3, so what will you do? So you just change this formula a bit. So s2 dot 1 3, right? So you will have your 2's over here. So summation x2 minus x2 hat whole square divided by n minus 3. Still the variable is same, that's why it's same. The only thing that we change is x2, right? And then in this formula as well, what we will do is that summation x2 whole square minus a times summation x2 minus b1 summation x1 dot x2 minus summation minus b2 summation x2 minus x3. The only thing that has changed over here is this as well. This one has not changed. This one has changed, and then basically this one has changed. Okay, that's the only change over here. These two have changed. Okay, that's pretty much it. Otherwise everything is same. So that's pretty much it, guys. If you have any questions until now regarding correlation, regression analysis, please do comment down below. I'll definitely be happily willing to answer them. So anything from this chapter, if you don't understand, repeat, pause, repeat, like if you don't even understand, then please do comment down below or send me a question, photos, anything. I'll solve it for you and I'll provide it to you. So until next time, bye bye.